Let's talk about reliability and validity. So these two terms at first glance might seem like they're interchangeable, like they essentially mean the same thing, right? But when it comes to research, reliability and validity are distinct. So each has its own separate meaning, and you need to understand the differences between the two terms. You also need to understand that good research needs to meet both standards. Good research needs to be both reliable and valid. And when we talk about reliability and validity, we are typically talking about these things in the context of quantitative research, research that uses numbers and statistics and measurement, because reliability and validity are all about measurement. Whatever it is you're trying to measure in your research, are those measurements reliable and are they valid? So let's talk about the differences between those two terms. So reliability refers to the consistency of measurement. In other words, reliable measurement would be if you did the same test and then you repeated it again and again and again and again, you should get the same result or the same measurement each time. If you do, that means the measurement is reliable. Whereas validity, on the other hand, refers to the accuracy of your measurement. In other words, are you really measuring whatever it is that you set out to measure? So if that seems a little confusing or convoluted, let's talk about some examples of reliability versus validity. Let's assume, for the sake of argument, that one of the variables in your hypothesis or research question is intelligence. Now, I know that intelligence is not likely to be a variable that very many of you are focused on in your own topics that you're interested in, but let's just run with this for the sake of argument. Let's say you're trying to find out whether, I don't know, people who use social media a lot are more or less intelligent than others. So one of the things you're trying to do in your research is you're trying to measure intelligence. Okay, let's say you have this crazy idea that the way you're going to measure someone's intelligence is to take a tape measure, wrap it around their head, and whatever that measurement is, that's their measure of intelligence. In other words, the wider their head, the more intelligent they are. Okay? Now, I know that sounds crazy, which we'll talk about in just a second here. Question, first of all, is that a reliable measurement of intelligence? Now, you might immediately say, well, no, of course not. That's not reliable. Actually, it is reliable. In fact, it's very reliable. So it is a highly reliable measurement of intelligence. And if you're wondering, how can that be? Well, think about it for a second, right? If I took the tape measure, put it around my head, and however many inches it said, that was my measurement of intelligence, okay? And then I asked another person to take that same tape measure, wrap it around my head, and see what number they get. And then I asked a third person to do the same thing, right? We would all get the same number. Because when you measure something with a ruler or a tape measure, there's very little room for error and very little room for interpretation. So the results you get would be consistent. They would be reliable, high reliability. And then you say, yeah, but that would be a really stupid way of measuring intelligence. And you're right. And that brings us to the second half of the equation, which is validity. Are you really measuring what you set out to measure? No, of course not. You know, measuring the circumference of someone's head is not an accurate way of measuring their intelligence. So it would obviously fail the test of validity. So it would be highly reliable, but it would be invalid. And remember, it has to pass both tests in order to be good, in order to, you know, meet the standard that you're trying to achieve, okay? So that's an example of the difference between the two things. One more example, if you think about a clock, okay? And let's say in the spring, you forget to set that clock ahead an hour. So it keeps track of time reliably, consistently, right? But the time is always going to be consistently wrong because it will be consistently an hour off. So that would be another example where you have reliability. The clock is a reliable way of measuring time, but you have no validity because the time that it's giving you is inaccurate. It's always an hour off. High reliability, but low validity. One more example that sometimes helps is to think about target practice. So you see the example on the left here on the slide, target A, where someone is aiming for the target and they're missing every time. None of their shots land right in the middle. But you'll notice their shots all land in pretty much the same space, just, the wrong space. So again, their shots were consistent, right? So they were a lot reliable, but they didn't hit the target, so they were invalid. Poor validity, good reliability. The example in the middle, target B, there once again, they're always missing the target, therefore poor validity. And this time, the shots aren't even consistent. They're all over the place. Poor reliability. And then the final example, target C, there, all the shots are consistent because they're all pretty much in the same place. And the place that they're in is exactly the place that they should be in. So you've got good validity as well. Now, a couple of things you should know. First of all, when you do research, you're never going to have perfect reliability or perfect validity. Your goal is to do as good as you possibly can, right? Getting back to intelligence, for example. We said that measuring the circumference of someone's head is not a valid measure of intelligence. Well, what is a valid measure of intelligence? What we have typically used is an IQ test, right? Some of you have probably taken IQ tests. You take the test and then it gives you a number and that's your IQ. Is that a valid measure of intelligence? Well, some people would argue no, because some people have argued that those IQ tests tend to be biased against, people of certain backgrounds, economic backgrounds, racial or ethnic backgrounds, that maybe those tests are not a valid measure of intelligence. But if they're not, what's the alternative? Do we have anything that is better? There may be no perfect measurement of intelligence, but we want to find something that comes as close as possible to capturing that concept or that variable that we are trying to measure. Understanding that we will probably never have complete alignment between what it is that we're trying to measure and what it is we're actually measuring. There's always going to be some degree of slippage, but we want to try to achieve as much validity and as much reliability as is humanly possible.